everyone. Can you hear me? Hear my voice well? Okay, great. Thank you so much for participating in this session, Technology and Data Collection for Peatland Management, jointly coordinated by Japan International Cooperation Agency, UNEP, and GPI. I'm Misaki, a co-moderator, together with Ms. Budi Susanti. This session is a hybrid, so I expect many people are joining online as well, from all over the world. For the online participants, please feel free to leave your questions on the Q&A corner on the right side of your screen. And yeah, in this session, we are going to look at three critical elements for peatland management. One is policy, technology, and capacity building on the ground. We invited speakers from Japan, the Democratic Republic of Congo, Peru, Indonesia, and Italy for these topics. Hope you have a fruitful time for next 90 minutes. And now I'm pleased to welcome Mr. Takashi Nishimura, Deputy Director General of the Global Environmental Department of JICA, to open this session.
Good morning, ladies and gentlemen. Welcome to the Peatlands Pavilion. I am Takashi Nishimura, Deputy Director General, Global Environment Department of JICA. In opening the event, Technology and Data Collection for Peatland Management, which is organized by JICA, UNEP, and GPI, I'd like to give my remarks on behalf of JICA. First of all, I'd like to express my gratitude to everyone for your interest and participation. Special gratitude to co-organizers, UN Environment Program, Global Peatland Initiative. Special thanks to this event's speakers and moderator, Dr. Mitsuru Osaki, Dr. Jean-Jacques Bambuta, Mr. Jose Alvarez Alonso, Dr. Kazuyo Hirose, Professor Dr. Koneu Ewango, Mr. Tsuyoshi Kato, Ms. Niken Andika Puturi, Ms. Maria Nutinen, and as a moderator, Ms. Sri Parwati Murwani Budi Susanti. And special appreciations to the coordinators of Global Peatland Pavilion Program for COP26 and Mr. Onaka, JICA advisor to DRC, for his contribution to the event. Peatlands cover less than 3% of the Earth's surface, but hold the largest terrestrial organic carbon stock in their soils. Considering the role of peatlands as a carbon stock, the loss of peatlands needs to be prevented with proper management of peatlands. Through proper management of peatlands can contribute toward achievement of the SDGs, specifically reducing greenhouse gas emissions, maintaining ecosystem services, and securing lives and livelihoods. The importance of peatland management as a means of providing a nature-based solutions has been widely recognized as the international community, while well-defined policies are necessary for the proper management and sustainable use of peatlands. It is essential to understand the distribution and the use of peatlands as accurately as possible. Peatland science can help us to understand the ecological mechanisms of peatlands, and peatlands technology can help us to understand peatlands resource availability, both of which contribute significantly to peatlands management. This side event will provide a series of JICA's work on peatland management in Peru, the Democratic Republic of Congo, and the Republic of Congo. Government officials from each country will present the challenges they are currently facing, the direction of future policy and measures, and their expectations for information development and monitoring technologies. The presentations will also focus on peatland mapping and introduce a new possible methodology for peat mapping using a combination of optical satellite data and synthetic aperture radar. The result of a peat boring survey in the Democratic Republic of Congo, which was used as a field verification for mapping, will provide new insights. In addition, during this event, a private company, Sumitomo Forestry, will present its new peatland monitoring methodology with small satellites in Indonesia. And an international organization, the Food and Agriculture Organization of the United Nations, will talk about capacity building for peatlands management. Through the side event, we will reaffirm the importance of the role of science and technology, and we hope that audience will obtain new knowledge on peatlands monitoring and mapping. Global partnership and knowledge sharing is indispensable for peatland conservation that leads to tackle climate change and achieve the SDGs. Thank you for your attention.
Thank you so much, Mr. Nishimura. And from now on, I'd like to hand over the moderation to Ms. Budi Susanti. Please come.
Very good morning, and good afternoon, also good evening, depend on where you are right now. It is my pleasure to be here as the moderator, as the end valuable session, so-called the technology and data collection for peatland management that co-host by the JICA, UNEP, and GBI at the 9th days of the COP26 UNFCCC in Glasgow. Okay, the science and technology of the peatland is especially for mapping, data collecting, and also monitoring is very valuable and essential for us to measure what the countries have done so far in the peatland conservation and sustainable management. So we can measure, we can verify and reporting what we have done so far and accurate data with supported by the technology that we will discuss in this session. No further delay, I would like to introduce the present expert that already here will present some experience across the world and also the technology that have been developed to support the collecting data, monitoring, and mapping. The first one is Professor Mitsuru Osaki, and he will present about the peatland measurable mapping and also the redox in the greenhouse gas emission. The second presenter is Dr. Jean-Jacques Bambuta, that is already here. He will present about the peatland management from the DRC experience. And the third presenter is Mr. Jose Alvarez Alonso, the Director General of the Biological Diversity from the Ministère del Ambiente, Peru, that will join with us from Peru. He will present on the peatland management in Peru. The fourth, Dr. Kayusa Hiroshi, the Director General for Japan Space System, that will present regarding on the peatland mapping by latest remote sensing data in Congo Basin. And the fifth speakers is Dr. Corneli Evango, that will present about field data collection of the peatland in the RC. And Mr. Kato, I know well, I know him well, and Ibu Niken will present regarding on the experience in the monitoring and with the new technology in Indonesia. And also the last is Maria Nutinen. Miss Maria Nutinen will join from Roma. He will present the capacity development for peatland from science and practice. No further delay, because we have a limited time for these 7 speakers. We would like to invite Prof. Osaki to present starting this session, and your time approximately 8 minutes. Thank you very much.
Good morning, ladies and gentlemen. So my title is Evaluation of the Giga Ecosystem based on the Giga's entropics. What is a Giga ecosystem? That is based on the Giga data set, the, which get the data using the real time. Can you follow? The real-time the monitoring systems, not what to say event data. And so, for example, water cycle, nitrogen cycles, and carbon cycles, and also the forest functions. And so, GIGAS is a global informatics based on the grid analysis systems. So, maybe you know we have done the long time studied in Indonesian Peatland, almost 30 years. We developed the methodology for evaluation and management, the systems. And so now the stage is to extend this knowledge and technology to some another Africa and for the South America, Brazil, Congo, Colombia, or so on. Sorry, next one. Okay. So we are thinking what is the Giga, the ecosystem. You know that we are study about mainly the peatland, but you know the peatland affect several factors or several ecosystem or interactions. This is, for example, in the case of the Borneo, this is we estimate the big, the giga, the ecosystems, which is mutually interacted between ecosystems. For example, the center of the Borneo, the mountain areas, we are thinking the high carbon reservoirs and also the water reservoirs. Because of the, you can see also the peat in the mountainside, and also use the bottom. So also this is related to carbon and water reservoir ecosystems. And if destroy we call that is the pool, or top is towers. So if destroy each of them, so the drastically affected to another ecosystems. Next one. For example, the human impact, the forestry decreasing, and so mountainside, the carbon water stock, the tower is destroying. Maybe so this, the water supply to the bottom is also disturbed. Then so the totally, if we conserve the peatland in the lowland, but the total ecosystem is destroyed. So next one. So how to evaluate this ecosystem. So next one. So now we propose a very excellent technology. This is what to say, the hypersensor technologies. Because of the using a hypersensor, so you can see the what to say, left side from you. So this is you know the normal the satellite. For example the spot or Landsat or so on. This is almost 10 band, and can estimate, for example, the green. But if you apply the hypersensors, so this green separated to several factors, maybe nutrient, disease, and so growth condition or so on. Then so we can use technology to evaluate the giga ecosystems. Next one. This is for example, we collaborated this technology with JAXA and GSS Hiroshi-san. And so we estimated, for example, biodiversity. This is using the UAV, and you can see the one dot is one trees. So this is the first time to evaluate what to say tropical, the peatland and forestry, and we showed high biodiversities. And in the past, almost difficult to, for example, next one is a forestry degradation and mapping. And so using the new technology, we can estimate the forestry degradation and deforestation and the several, and also we can see the, what to say, the peatland, the degradation and erosion of the organic matters. And also we can estimate using this the hypersensor. So this is very powerful. Then so we can apply this technology to evaluate giga ecosystem. If have no technology, this kind of no technology, it's impossible. So now the stages to the evolution, the technology and evaluation systems. Next one. Okay, so now so we propose the evaluation, estimation, the peatland, not only the Indonesia, now so Africa, also the Peru and the Brazil Amazon. Then so how to evaluate the ecosystem, because which is totally different. And so if apply this kind of the hyper technology, maybe so some another the satellite technology, so we can develop the evaluation system and management system. Thank you very much.
Perfect time for Professor Osaki. Thank you very much. He is a suhu for us in terms of peatland science. So thank you for being here, for sharing the valuable technology for valuation. Next speaker is Dr. Bambuta. We would like to invite you in the second speaker. Thank you.
Morning, good afternoon, ladies and gentlemen. I'm Jean-Jacques Bambuta from Democratic Republic of Congo. I'm working for the Ministry of Environment and Sustainable Development, and I'm in charge of peatland in DRC. So you have the English version of my presentation, but I will make some comment in French. Don't worry, because this is also an opportunity for you to improve your French, as I'm improving my English. Mesdames et messieurs, en tant que délégué de la République démocratique du Congo dans ce pavillon, je voudrais, au nom de monsieur le secrétaire général, remercier nos amis de la JICA qui nous ont associés à cet exercice. La technologie, la collecte des données, le suivi des tourbières sont importantes pour nous, République démocratique du Congo. Alors, je voudrais ramasser ces éléments-là, mais le replacer dans le contexte qui est celui de l'élaboration d'une politique nationale des tourbières. Et donc, je vais revenir sur deux choses. Le premier élément, c'est le contexte de gouvernance des tourbières en République démocratique du Congo. Et pour finir, je ferai un petit pont vers le développement des connaissances sur les tourbières. Alors, nous, en République démocratique du Congo, nous avons commencé à adresser la thématique tourbière en commençant par une sorte de roadmap. Donc, nous avons défini une feuille de route. Et cette feuille de route, elle est essentiellement... I mean, you are lost also, hein? Okay. I can go on with my English. Et donc, je disais que nous avons commencé par définir une feuille de route. La feuille de route a comme activité principale l'élaboration de la stratégie nationale des tourbières. Mais celle-ci devra se faire à base des 2 piliers. Le premier pilier, ce sont les consultations. Je l'ai déjà dit dans ce pavillon. Donc, vous allez souffrir que pour ce qui concerne le contexte, que je revienne sur un certain nombre de choses. Et le deuxième élément qui va appuyer l'élaboration de la stratégie nationale ou de la politique nationale des tourbières en République démocratique du Congo, ce sont les études multisectorielles. Dans ces études, nous avons la cartographie, nous avons l'inventaire et nous avons le suivi, et on a aussi d'autres études que je vais énumérer. Donc, vous comprenez qu'il y a une importante jonction à faire entre les études et l'élaboration de la politique. Alors, depuis que nous avons commencé la thématique, nous avons déjà réalisé un certain nombre de résultats, parmi lesquels je peux citer en termes d'études la revue du cadre juridique, parce que comme vous le savez, l'écosystème tourbière est connecté à d'autres thématiques. Et pour cela, pour pouvoir adresser une politique des tourbières, il faut aussi regarder ce que les autres thématiques disent, qu'il s'agisse du foncier, qu'il s'agisse de l'aménagement du territoire ou qu'il s'agisse même de la production des moyens de subsistance. À ce niveau-là, je voudrais quand même remercier nos collègues de US Forest Service qui nous ont appuyés pour la réalisation d'un certain nombre d'études, dont le revue du cadre juridique. D'autres études sont en cours. C'est essentiellement l'évaluation des menaces qui pèsent sur les tourbières. Nous voulons aussi voir s'il y a des zoonotiques qui peuvent partir, qui peuvent avoir comme cadre d'émergence les milieux de tourbières. Et on voudrait s'interroger sur le niveau de l'hydrologie qui peut être accepté par les tourbières, mais aussi identifier les menaces climatiques qui peuvent peser sur les tourbières. Tout cela, c'est pour que nous puissions avoir une stratégie qui tienne compte des données scientifiques. Alors, le grand problème de la RDC, je l'ai déjà dit dans ce pavillon, c'est la cartographie, avec comme question fondamentale, où sont les tourbières de la RDC? Derrière vous, vous avez une carte qui indique en fait une première dispersion des tourbières de la RDC. Mais nous pensons que des études sérieuses doivent être menées afin que nous puissions avoir des cartes qui soient acceptées par tous sur base des méthodologies qui soient acceptées par tous. Et donc, notre grand problème, c'est la cartographie. Et c'est très important. À cela, nous pouvons ajouter l'évaluation du stock de carbone. J'en viens donc maintenant à ma deuxième préoccupation. We can move. Next slide, please. J'en viens donc à ma deuxième préoccupation qui est le développement des connaissances sur les tourbières. Alors, depuis 3 à 4 ans que nous parlons des tourbières en République démocratique du Congo, nous avons ce problème-là de connaissances. Qu'est-ce que nous disons lorsque nous parlons tourbières? Pour ceux qui avaient participé à la 3e réunion de l'initiative mondiale sur les tourbières, qui était organisée à Brazzaville, nous avions déjà à l'époque souligné l'importance du développement des connaissances sur cet écosystème. Parce que nous parlons d'une thématique émergente pour laquelle beaucoup de choses restent encore à identifier, beaucoup de choses restent encore à adresser. Alors, si pour des processus comme la RED+, le schéma que le pays devrait emprunter était plus ou moins clair depuis parce que c'était défini par le COP, mais pour la tourbière, chaque pays est en fait en train de vouloir monter sa politique de sa manière. D'où l'importance de pouvoir reconnaître un travail qui peut être fait, par exemple, dans le cadre de JPI, pour que nous puissions avoir des méthodologies communes pour pouvoir développer une stratégie ou une politique nationale des tourbières. Alors, d'où l'importance de la science, l'importance de la technologie. Je viens de dire ici qu'il y a des besoins en termes de connaissances. Donc, il va falloir tenir compte de tous ces éléments. C'est pour ça que la RDC est très contente du travail que nos collègues ou nos amis de la JICA sont en train de faire en termes de collecte de données de base dans la cuvette centrale. Mais nous, on aimerait qu'on puisse tenir compte aussi des autres tourbières qui ne sont pas que dans les provinces habituellement dont nous parlons chaque jour. Et pour finir, vous voyez que nous sommes plus ou moins avancés dans ce processus de pouvoir élaborer une stratégie nationale ou une politique nationale de tourbières. Et chaque année, nous avons l'opportunité de pouvoir organiser de forums ou de grands ateliers. Et donc, nous vous invitons déjà en fin janvier ou en février pour que vous veniez aussi à Kinshasa, échanger avec nous sur ce que vous êtes en train de faire. Mais nous pensons que ce travail que la JICA est en train de faire dans notre sous-région doit aussi être l'opportunité non seulement de pouvoir collecter les données, mais aussi de renforcer les capacités. Parce qu'il est important qu'au niveau local, qu'on puisse avoir des capacités qui seront mises à profit non seulement en termes de cartographie ou de suivi de stock de carbone, mais aussi en termes du suivi même de cet écosystème tourbière dans son ensemble. Mesdames et messieurs, voilà mon petit baratin que j'avais à faire. Je vais m'arrêter par là. Merci.
Thank you very much, Dr. Bambuta. He spent the time 6 minutes. So, in the last conclusion from him, he mentioned that the technology, science, and also research is very important for the development of knowledge of peatland. Therefore, he also mentioned the RC invite researchers to inform national policy on peatland and formulate important recommendation. And last, he also very welcome for the basic data collection by JICA and JAFTA in Congo Basin. It seems that I can speak French fluently. Okay, thank you very much. And now the third speaker is Mr. Jesse Alvarez Alonso that will join with us from Peru. He is the Director General from the Ministère del Ambiente, Peru. He would like to present the peatland management in Peru. Dr. Alonso, the time is yours. Thank you.
Thank you very much. Good morning from Peru. Good afternoon in Glasgow. Greetings for everyone. I will speak in Spanish. It's an official language in the COP. So thank you very much. Did you see the screen, please? Can confirm me? Thank you. En Perú tenemos unas turberas muy extensas y muy importantes para la seguridad hídrica, especialmente en la zona andina, donde tenemos turberas que son importantísimas para almacenar y filtrar el agua de la que se sirve especialmente la costa del Perú, que es un desierto. Y por supuesto son importantes también para el cambio climático. El Perú es el tercer país, después de Indonesia y Congo, en extensión de turberas tropicales. Y las turberas también tienen una enorme biodiversidad. Por ejemplo, en las andinas hay aves tan raras como el Cinclodes palliatus, ahí en la foto, que es un ave endémica de esta zona del Perú. En la Amazonía también hay una enorme diversidad en las turberas amazónicas. Están especialmente distribuidas en Amazonía y en los Andes. Ahí tenemos la extensión. En Amazonía son más de 6,5 millones de hectáreas. En los Andes son más de 500 000 de hectáreas. En total tenemos una extensión de 8 millones de hectáreas o más de turberas entre Andes y Amazonía. En la costa un poquito menos. La zona más extensa de turberas es en la Amazonía norte del Perú, donde tenemos una enorme reserva de carbono en la turba de estas turberas, más de 3.1 mil millones de toneladas de carbono, que representa el 40% del carbono arriba del suelo en el Perú. Esto a pesar de que es un área que es apenas el 3% del área boscosa del Perú, que tiene 68 millones o 70 millones de hectáreas de bosques. Y muchas turberas que están protegidas en el sistema nacional, como vemos ahí en manglares, en la costa norte del Perú, turberas andinas, hay varias áreas protegidas, y las turberas amazónicas también en varios parques nacionales y reservas nacionales. Las turberas andinas han sido manejadas tradicionalmente con mucha sabiduría por los pueblos andinos. Han tenido una relación extraordinaria porque no solo las han manejado, las han aumentado haciendo canales de irrigación para saturar esas zonas porque son importantísimas para los pastos, para su ganado, la vicuña, la alpaca, la llama, y son importantísimas como reserva hídrica en el tiempo de verano y tienen una relación cultural y religiosa con estos ecosistemas muy importantes. La Amazonía las comunidades indígenas utilizan estas turberas especialmente para el aprovechamiento de frutos. En concreto, la palma más utilizada y más abundante es la que se llama Mauritia flexuosa. En Perú es el aguaje, en Brasil le dicen burichí. Es una de las plantas más abundantes de la Amazonía. Son varios miles de millones de estas palmeras que hay, que dan un fruto enormemente sabroso, nutritivo, muy importante para la fauna silvestre, de la que también se alimenta la gente, y que actualmente es muy consumido por la población y es transformado por la industria, empezando ya a vender en varios países tanto cosméticos como bebidas y otros productos. Esto está creando una fuente de ingresos muy importante para las comunidades y se convierte en un incentivo importante para conservar estas turberas. Sin embargo, las turberas tienen también una serie de amenazas. En los Andes, por ejemplo, se sobrepastorean, hay una extracción de turba ilegal que se está tratando de controlar, y cuando están muy secas también a veces se incendian. En la selva, lamentablemente, hay tala de estos árboles de palmeras de aguaje para cosecha de frutos, que se está también tratando de controlar, pero que es muy destructiva. También están destruyéndose en algunos lugares para minería ilegal y en la costa por cambio de uso. ¿Qué hacemos para conservar estas turberas? Movemos estudios e instrumentos orientadores. Conducimos, por supuesto, la Estrategia Nacional de Humedales para conservar las turberas dentro y fuera de áreas protegidas y los sitios Ramsar, varios de los cuales están fuera de áreas protegidas. Y contribuimos con ello al cumplimiento de las metas nacionales y a los compromisos internacionales. ¿Qué promovemos? La conservación de los humedales, como hemos dicho, la conservación, por ejemplo, de los aguajales, estos pantanos de palmeras tan extensos, más de 6.5 millones de hectáreas en la selva, a través de bionegocios. Trabajamos con varios proyectos de cooperación, tanto en la selva como en el Ande, y estamos trabajando ahora en la identificación y mapeo de turberas. Para esto, JICA nos está apoyando mucho con tecnologías muy sofisticadas que ayudan a precisar la extensión y ubicación de estas turberas. Y también estamos promoviendo una nueva medida de mitigación de turberas, NDC, para turberas amazónicas, trabajando también articuladamente con autoridades locales. Para eso se ha publicado recientemente un instrumento nuevo, un decreto supremo que establece las reglas para la gestión multisectorial de las turberas, porque hay varias autoridades involucradas. Promueve también la investigación y promueve el uso sostenible. Prohíbe algunos usos no sostenibles, como por ejemplo la tala de palmeras o la extracción de turba en las turberas andinas. Y sobre la NDC para turberas estamos trabajando para permitir que tenga este stock de carbono, se conserve para el futuro y se minimice el impacto. Estamos avanzando, por ejemplo, con 12 secciones de la NDC o NDC. Estamos en plena revisión de la sección del cálculo de potencial de mitigación, para la cual es vital avanzar en la identificación de mapeo. Y para eso, como repito, contamos con la cooperación internacional. Esperemos que pronto tengamos bien mapeadas y bien identificadas y con medidas de gestión las turberas. Estamos impulsando medidas complementarias como OMEC, otras modalidades de conservación y gestión efectiva basadas en área para las turberas fuera de áreas protegidas. Eso sería todo de parte de Perú. Thank you very much. Welcome.
Okay. Thank you for the presentation, valuable. It is wonderful to see the biodiversity in the peatland, tropical peatland in Peru, since Peru is the third tropical peatland in the world after Indonesia, the RC, and then Peru. And currently promoting for the monitoring and also how the technology will valuable to support the performance on the peatland management and also in contributing the NDZ in Peru. Now we come close to fourth speaker. We would like to invite Dr. Keiyusa Hiroshi to present the satellite data that will support us for the peatland management and
Okay, thank you very much. Today, I would like to introduce the Peatland mapping by remote sensing data in Congo Basin. Next, please. So JICA, sorry, I cannot see the slide. Okay, so JICA launched the data collection survey for global cooperation of peatland management and protection to study the cooperation potential in Indonesia, Peru, and the Congo Basin. The survey in the Congo Basin aims at collecting the information related to peatland management and protection and analyzing the cooperation potential in Congo Basin. The survey covers methodology development for mapping peatland using Japanese satellite data and others with some ground truth to verify the bordering of peatlands to enhance the accuracy of remote sensing mapping technique. Next, please. So Congo Basin, that is the very big potential to store the huge amount of carbon. So the area and the carbon pool of peatland in Congo Basin are estimated as 145,500 square kilometer and 30.6 gigaton. This is a great achievement from the Darji and Congo Pito project. And now JICA is developing a methodology for mapping peatland in Congo Basin with the modification of the methodology developed in Peru. Next, please. So this is just an overview of the methodology of peatland mapping in Peru. The JICA developed the peatland mapping methodology in Peru from 2016 until this year. The basic concept is the second one. This one, the methodology was designed to utilize the open source software with free satellite images for sustainable management of wetland forest of Aguaje. So it means everyone can start the satellite imagery for peatland mapping from now. So the methodology use the optical sensor and the microwave sensor and the digital elevation model. Okay, next please. So this one, the methodology for peatland mapping in Congo. So previous methodology developed in Peru use the mainly Sentinel-2, but here for the Congo Basin, we add the pulsar fine beam mode. So this one is very useful. So HH polarization, but the all data is acquired in the rainy season. So it means we can discriminate the wetland area such as forest peatland. So pulsar FBS HH polarization is very useful. Okay, next please. This is the result, the analysis of the Sentinel-2 optical sensor. So we use 9 channels. So we can discriminate peatland vegetation from other vegetations clearly. Next, please. And also this one, the backscatter characteristics of the peatland, the vegetation. You can see the peatland vegetation has more than minus 5.5 decibel. Okay, and the other vegetation is less than minus 5.5 decibel. So we can discriminate the peatland vegetation. Next, please. This is a result of Sentinel-2 and the pulsar analysis. So we can extract peatland vegetation, and you can see the yellow boundary. That is the peatland area. And the blue one, this is a very important data prepared by Greifswald, the Meyer Center. So we can compare the result of analysis with the existing peatland mapping data. Okay. So next, please. So based on the such analysis, we can apply the spectral characteristics of Sentinel-2 and backscatter characteristics of pulsar 1. Then finally, we can compare with the Congo peatland map. So almost our result is corresponding to the map created by Congo Peat and Darji et al. Okay. Next, please. Then this idea we applied to the new area around Nioki, that is the south end of the Congo basin. Then we can identify the potential peatland area like this. So blue one is potential peatland area, and next speaker will present the result of field survey. Field survey transect is the blue dot. There are two transects. Okay. Next, please. Okay, so JICA is the developing methodology for mapping peatland in Congo Basin with the modification of the methodology developed in Peru. And the preliminary result of spectral analysis of Sentinel-2 and backscatter analysis of pulsar suggested potential peatland forest in Nioki area, Maidombe. And the field survey was conducted at Nioki area from September to October this year by the Congo or DRC Congo or expert. And the peatland of 350 centimeter thickness in the maximum were found at Nioki area. That was suggested by a preliminary result. So our approach was verified by field survey. Okay. So thank you very much.
Thank you, Mr. Kayuso Hiroshi, Director General for Japan Space System, for sharing us regarding on the satellite imagery for mapping and monitoring in a peatland area in Congo Basin. So it seems that I asked you all to running this session. Sorry for that because we have a limited time. So I would like to invite the next speakers, Dr. Alonso. Dr. Afongo. Yes, Dr. Evango to join this session from far away using the field tool. So we can listen from them several experience that have been conducted. Thank you very much and your time.
On est certain. Voilà la courbe ici. Oh, hein. Waouh! Quelle végétation!
Et 80. 3 mètres 80 avec l'autre 2 mètres 80, donc on peut arriver à près de 2 mètres de profondeur. Il y a encore des traces de litière qui sont visibles. Et ce qui veut dire que non, la tourbe va beaucoup plus en profondeur comme on le pensait.
Et comme vous le voyez, ça c'est vraiment une tourbe typique. Nous avons dit que la tourbe est constituée de débris de matière organique partiellement décomposée. Et à 65% des matières organiques qui restent partiellement décomposées, c'est encore une tourbe. À environ déjà 180 mètres, vous voyez encore des particules de feuilles. Mais ce qui est très intéressant, c'est qu'on observe à 180 cm, donc à 1 mètre. Et probablement, comme nous sommes dans les raffias, vous voyez encore comment la zone est poreuse avec des matières organiques. C'est pourquoi nous faisons un effort d'inventorier. Il n'y a pas que l'importance de la tourbe, mais il y a aussi la biomasse aérienne. C'est ça l'importance même des forêts de tourbières, car ils sont en train de stocker le carbone, mais la forêt est en train de séquestrer le carbone. Donc c'est un mécanisme double qui montre l'importance des forêts de tourbières dans le cadre dans cette période de changement climatique. Can I start?
Yes, please. Thank you.
Good morning, everybody, and greetings from Kisangani, the Democratic Republic of Congo. This is a special event for me because I was just born last night. So you guys will be celebrating my presentation with data collection to assess carbon stocks in tropical peat soil in Maindombe peatland. That's the Nyoki region at the Ministry of Environment, collaboration with the University of Kisangani. Next. Next, please. Yeah, the mission ad as sampling, as you know, the peatland that were discovered in the Congo Basin still not delivering all the scientific information we need to understand the peatland of Congo Basin. That is, we need ground truthing data collection for not only mapping, but also characterizing the vegetation and also all the other parameters that are associated with the forest and the carbon sequestration and also carbon stocking on the ground for those peatlands. And for that, we need more information on the ground. So since there, we have started mapping peatland in the Congo Basin and the DRC side by the province of Ecuador, and we move large area of peatland been remained behind of Maindombe. That area, it's giving from the interior of
Dr. Evango, can you hear me?
equatorial forest to the transition of.
Hello, can you hear me, Dr. Evango?
Okay. I
Okay,
hear you, but
your voice is a little bit cut it down, so maybe
it's not working properly. I don't know.
maybe you
What's
can
wrong?
like repeat like 2 minutes before and with a little bit more like slower, please. Sorry.
My video is not working.
It's fine. Yeah, you can turn off your video so that I keep the connection. Yeah, you can turn off your video. Ah, thank you. Okay, so please just repeat like 2 minutes before.
It's not working. So can I go like that without video? Anyway, so I was saying that Maindombe area is important for the DRC peatland understanding because it's giving the transition from the interior of the Congo Basin forest and the transition to forest savanna. And so it's very important because it has an ecosystem that might be, we expect it to be different from the forest to the savanna transition. And that is also largest lake, the Lake Maindombe, that is suffering also by logging, forest logging surrounding that logging is affecting the peatlands and also the water table of the lake. And it has largest rivers that is surrounded by the peatlands and also provided water to peatlands by the peatlands. And for that, we need more data to complete our understanding or our mapping of the DRC peatlands. Next, please. Next, please. Yeah, so this is the preliminary analysis of peatland. The first one we are handling on Maindombe province. And the data we collected are just to start the mapping and also characterizing the forest vegetation and habitat type within the peatlands of Maindombe. So this is just what we collected. It's according to the methodology. So we are collecting the, assessing the vegetation and also sampling through the region. So the site and peat type, sampling the depth of the, how deep it's those site or peatlands. And we would like to have an estimation of bulk density and carbon content on those peatlands layers so that we come up with the first estimation of the total stock of carbon within the Maindombe peatland, but also contribute to improve the mapping, the remote sensing mapping that all the colleagues have started presenting. So we need more data from the field so that we complete that effort also. So this is the preliminary analysis that we have just started. Next, please. Next, please. So considering that we're still going with analysis, some of the parameters that might give us the total stock of carbon are not yet evaluated because all the laboratory analyses are undergoing in this site. So what we have got as a preliminary result, so we launch our inventory on 2 transects, 3 kilometers each. So that means we have covered 6 kilometers of 2 transects. Within those, we collected 11 samples of core pits, but 1.1 site didn't have pit, and in total, we just evaluated on 10 pit cores. But within that, we're still processing the data and on the lab. So we did just 82 cores, the pit cores that we are presenting the result here. What have we got on that? So for sure, like us, we have got the pit. There is pit. So how deep it was, we went up to 3.5 meters, and we have got about for the pit, it's the average of 2.2 meters on the first and 2 meters on the second transect, and that gives us an estimation of 0.15 bulk density and 5.5 of carbon content for the first, and almost the same also 0.1 and 8.707 for the second transect. What is important and interesting here, we have got also open grass area with peatlands, and within that peatlands that makes enough carbon content than any site we have got inside the forest, being it the palm swamp dominated or hardwood forest and combine it with mixed forest. It gives us 10.9% of carbon content. That's quite extraordinary, whether it was only 80 centimeters. That's quite very interesting to see that we are coming up with some other type of habitat type within the peatland that we didn't recover by the remote sensing map, but just got it through the ground truthing expedition. Next, please. And within that, what have we got? We just, for this purpose, calculated, evaluated the bulk density and the carbon content. As you can see, from the depth, here just we used the data that brought us to 3.10 3 meter 10 centimeters only, because the last one of 3 meter enough, we didn't made all the analysis, so it's not included here. But what you can see is that from the bulk density to carbon content, it changes from the depth. So the top soil or the top peatland surface has low bulk density and low carbon content. That is because it has more humus. It's very humic and with a lot of detritus that are visible even by eyes. But when you go in the intermediate depth, you see that there is high density of bulk density, and that has also high carbon content. And it quickly reduces when you go deeper. That's because of early intrusion of mineral soil that is coming and mixing with the peat, decreasing also the bulk density and the carbon content. So it's very interesting to see that the bulk density and carbon content is function of the decomposition rate of the peat and also the depth in that area. This is very interesting to see, compare it to what we have done already for 3 years in Equator province in the north, and this is in the south of the Equator line. So giving us another history that is really leaving more and more question to continue mapping the entire area of Maindombe that used to be very specific compared to the central Congo basin. Next, please. Next, please. So this is just to show you how was you have seen it already on the movie, but this is giving you the real impression on the ground during the expedition mapping. It was not only mapping and collecting, but it was also part of teaching. So building capacity of our Ministry of Environment scientists to get involved deeply involved on the mapping and vegetation characteristics of the peatland of Congo. The area is very large and few people are working on. So we really need strong team and inspired team to continue covering the peatland mapping in the Congo basin. Next, please. Next, please. Yeah, as I see, I can say, so considering the technology and the technical issue, we need really to go far with the mapping on the ground. So reliable depth estimates require numerous points measurement in the field, which don't exist for most areas in the Congo Basin, and many large-scale pit volume estimate use just the average, so from a point sample. But we need to cover large areas so that we come up with accurate estimate of the stock of carbon and the volume of peat that might be stored on our peatlands. The measurement of bulk density and carbon concentration require careful sample extraction, as you have seen, and that is quite a very strong methodology that we can quickly cover the largest area of the Central Congo Basin pits. And it needs also a subsequent analysis using the basic laboratory equipment that we have done here in Kisangani. So the bulk density and concentration can vary spatially, as you have seen, throughout the vertical pit profile, resulting in complicated three dimension of carbon storage patterns. And it have been also found in Amazonian forests by other scientists, and it's almost, we are coming with the same conclusion in the Congo Basin. So that's very good. And therefore, we need more multiple measurement of carbon concentration and bulk density from sample taken at various depths that might cover profiles, soil profile or peatland profiles within the entire landscape. That would be great to have to come up with an accurate determination of carbon stock and also mapping of the Central Congo Basin peatlands. Next, please. And at the end, I would like to thank the JICA, who provided the funds for the Ministry of Environment, and in cooperation with the University of Kisangani and JAFTA to come up with recent results and with the uncovered area of Mindom. I hope that the interest is still being there and it's very large. So we are keen and very eager to come back in the field so that we continue. And thanks also to my university, we provided the permission for the field work and all the analysis that have been, are going to be done at the university soil biotechnology laboratory. So I thank them for their support on that. Next, please. Next, please. And thank you so much also to my team and my assistant who have been great and very strong enough. So we dare to explore and to continue by next year. Thank you very much. Enjoy your Glasgow COP and enjoy also to myself my happy birthday. Thank you.
Give applause to Dr. Efango from University of Kesangari. The presentation is valuable to show us the implementation of field data collecting, that we can see every peatland area have very different characteristics. So we have to check and carefully that proper and number of data. So now for the longer, I would like to invite Ibu Niken and also Pak Kato as the next presenter. Thank you. Your time is about 3 minutes. Sorry.
My name is Kato from Sumitomo Forestry, and I have been working in West Kalimantan for forest plantations and conservations for over 10 years. My colleagues is going to be give a presentation about this our activities, but I would like to share because I have happy news today. Our partner IHI successfully launched next please. Successfully launched their rocket. The name is rocket Epsilon Rocket 5 with several satellites early this morning. I would like to congratulate them very much. Now, Niken, please, please begin the presentations. Thank you.
Good morning, ladies and gentlemen. I would like to thank you to the committee for this opportunity to present on behalf Sumitomo Forestry. On this occasion, I would like to talk about the evaluation of eco-management of tropical peatlands. As we already know that tropical peatlands are highly important ecosystem for the storage and cycling of carbon and water and for high biomass production and biodiversity. However, despite being an essential ecosystem, the tropical peatland is very dynamic and is becoming extremely vulnerable due to the impact of climate change and human activities. For that reason, frequent and regular observation are required to understand the actual current condition of tropical peatland ecosystem and to help maintain their natural state. One of the challenges in managing tropical peatland is to provide saturated condition by keeping high groundwater levels throughout the year. The implementation would be much more challenging by the fact that the peatland ecosystem is not stable and changes dynamically based on its characteristic and environmental condition. The graphic on the left side shows how groundwater levels vary due to the difference in rainfall and location. The plantation forest is areas managed by Sumitomo Forestry which have been equipped with well-planned water management, while the natural forest is a protection forest which formed on a huge peat dome. The groundwater level in the natural forest dropped significantly during the severe dry season, while it was relatively stable in the plantation forest. Next. Due to the dynamic nature of tropical peatland and forest, an integrated system for monitoring, reporting, and verifying tropical peatland and forest is required to obtain and monitor useful information for proper peatland management. Further, the system must obtain information on the tropical peatland related to water and carbon, biomass production and biodiversity, deforestation and forest degradation, and climate change and human impact. Several sensing systems with specific sensor will be used depending on the purpose of the evaluation, such as peat subsidence, groundwater level, vegetation type, forest degradation, forest fire, and so on. And at the end, the system is expected to deliver real-time and high-frequency data, high resolution, high number and wide range spectral bands, three-dimensional analysis, and cost performance. Such systems are necessary because the tropic zone is frequently covered with heavy clouds for which frequent observation is an essential issue. The ground truth data are the most fundamental data used for validating any kind of remote sensing platforms. In this case, Spoteca, which is a real-time monitoring system, can be used for collecting the ground data such as groundwater level, rainfall, humidity,
wind speed, wind direction, temperature, pressure, solar radiance, and so on. The data is then stored in the cloud server and can be accessed in a real time by the users. Over the last several decades, UAV technology has been continuously improved and used in various of fields. By this time, UAVs with various types of sensor have been utilized in the peatland areas of Sumitomo Forestry. Among them is the use of UAVs for obtaining a topographic map, estimating pit subsidence, understanding the trend in the thermal information, preventing pit fires, monitoring wildlife, and detecting illegal logging. And in the future, the hyperspectral sensor is expected to supply more detailed information for mapping and assessment of the peatland ecosystems. As technology advanced, the IMRV system could consist of microsatellites constellation with several sensing systems and operated in the equatorial orbit, for which we call it as IEOS, or International Equation Observation Sensing Network. The objective is to obtain real-time information on the tropical zone, which is frequently clouded over, including early detection of forest fire and support for the restoration in order to achieve the negative carbons goal in the tropical zone. And in the end, I would like to highlight that the equator and the tropic are critical in preserving Earth's boundaries because of the dynamic of most ecosystems. And the IMRV system applied in tropical peatlands should be simple, low cost, high quality, and easy to maintain, because it will be meaningless if the technologies are not widely used by the national, local government, and communities. And last, the IEOS is necessary from the aspect of cost performance in natural capital and enhancement of the natural capital value on the tropic. Yeah, this is the end of my presentation. Thank you for listening.
Yes, thank you, Ibu Niken, and also Pak Kato for your presentation. You bring us from Congo Basin to West Kalimantan, and then you gave us listen how the implementation in the field should be confirmed by the data, satellite data. We have to integrate both source of data to make the confirmation that our data is accurate. Last but not least, our last speakers, Maria, how are you today? So hopefully I can see your smile from Rome. Now your time to present in this session. Thank you very much.
Thank you so much, Ibu Budi Susanti, Ibu Ati. Thank you. Yeah, thanks a lot. I understand I only have approximately 9 minutes, so I'll be very brief. But please do share some questions and comments also in the chat box and the question and answers part. This presentation is focusing on capacity development as requested by the organizers and succeeded by the European Space Agency. Thank you for that. And we have contributions from all our Peatland colleagues across the globe in today's presentation. So let me just take you forward. I hope this one works now. Yes, here we go. So today, well, I'll just take you briefly across this overarching structure about how we understand the capacity development here at FAO and within the UN in general, how we identify the capacity development needs, take those into account in the formulation, and then try to institutionalize and ensure the sustainability of these approaches. I'm very impressed to see all the examples that we heard today. And of course, the underlying reason why we need so much capacity development efforts, as requested, for example, by Dr. Bambuta today, is that a lot of the tools and approaches, both map, assess, manage, and also monitor peatlands are relatively recent. There are huge technological and data leaps ongoing at this very moment, and this is why we also need to develop capacity of all different actors who are involved in activities on different peatlands. So it's not a small task, but I think together we can arrive there. And I'm now about to share some cases, for example, how we've been dealing with this and why. First of all, let's look at the capacity development approach. What is, of course, has to be understood that no individual is working alone in this environment. There's the whole environment, which is either promoting and enabling or prohibiting some activities. No organization can do it by itself, and therefore we need to develop capacity both within the organizations. This means, for example, the capacity to retain knowledge, to share it further, to store the historical information and knowledge about peatlands, for example. And this is also another matter here in this slide. We are underlining the need for both functional capacities, which mean, for example, working in partnerships, generating good collaboration with partners, and then the technical capacities. For example, in our case at FAO, we are focusing on, for example, greenhouse gas estimates. We're focusing on remote sensing and field measures for peatland mapping, assessment, and also collecting the field data for monitoring. So some success factors that we've noticed during these years. So this is not only based on my experience, but also, for example, the UN RED program. Of course, in the preparatory phase, it's very important to identify the capacity development needs, identify who are the key stakeholders who can be helping to carry on the knowledge forward. The academia is, of course, in a key place here, but also private sector, as we just heard from Ibu Niken in the last presentation. Then about the formulation and implementation, that there is also this continued knowledge sharing that carries on alongside, the, for example, training activities. And then to go against the trend that the CAP trainings would be happening in isolation, we are trying to generate these online communities of practice, which allow for long-term engagement and joint learning and exchanges. Just an example of survey results. This is an upcoming publication about peatland knowledge needs and gaps that we did as a global survey in the past year or so. So these actors, survey participants, were identifying some of key topics where the knowledge and tools should be capacity should be developed. And there, one of the key topics that arose was the financial mechanisms and also better understanding of ecosystem services. Climate change mitigation was third, but as you can see, there were a lot of priorities among their stakeholders. One key aspect that we might need to focus, and I would invite all partners to think about how different actors can access financing. Half of the participants were not aware of any financing sources. Here's one example that also our colleagues, Dr. Hirose was pointing out, the training that we did on close collaboration with Dr. Bambuta also in the Ecuador province. Bandaka earlier this year, a joint design of training with Chrysler Meyer Center with the close participation of the US Forest Service and other SPAM partners. We were having participants both from the provincial level and then from the national institutions, with the objective of creating a low-cost, accessible method that can be used to verify remotely sensed probability maps and then verify that if they are correct, and making like more high resolution maps that can allow for local scale land use planning. So this was just one example. And of course here, this has been combined, the field mission was combined with almost a year now that we've been organizing these online sessions that still carry on. And we are really warmly welcoming, for example, JICA's participation to this session to contribute and developing capacity. Then about the demonstrating of benefits. Capacity development is often seen a bit of this fuzzy area, and how do you actually demonstrate that people have learned to do something, not only the knowledge level, but also to implement things. Here is just one example of a survey that we do right after an online session. This was from Peru, where we are trying to measure if the past session was relevant to their current and actual or upcoming and job-related tasks, and the results were very, very positive and encouraging here. Then another example from Indonesia, where we've been supporting Indonesian government in estimating, assessing and monitoring the peatland restoration impacts. And these were happening through two different tools, quite complex areas of greenhouse gas emission estimates, and then also remote sensing based CPOL tool, which is a FAO platform using, for example, Sentinel data. So we were having over 100 participants in this project for over 2.5 years from 14 different agencies were participating and developing that, we're hoping to develop their capacity. For example, through this kind of online videos, which is storing how to use the CEPAL platform for estimating soil moisture and soil moisture increase, monitoring it in the longer term. So this GIF and other materials, we'll share a link in the chat further later on how you can access these and the guidance materials. So here's the one result. Just to give a little flavor, we were of course having an interpreter for Bahasa Indonesia, which we found very important in here. Of course, even though many Indonesians speak excellent English, but having the trainings on the native language is very important and allows for different level of learning and sharing. And then another point, we have an online community of practice on mapping and monitoring, which we find very useful also to carry on exchanging and learning at all sides. This is just to share a couple of links. We welcome you to also join the online communities of practice. We'll post these links also to the chat later on, but over 90 from 90 countries, we have already over 1,400 members in one of the biggest communities here. So some key takeaway messages. I think I still have time. Just we warmly encourage, as so many new actors are coming also on working on peatlands, to carry on designing capacity development approaches in partnership, using stakeholder mapping, so to be sure that we are really inviting all the stakeholders who should be engaged, and using as much as possible the local languages. Turning from one-way communication to real open exchanges, as we are all learning here, is not just a one-way technological transfer, let's say this way. Then also the 3 stages of assessment: before, during, and after the sessions, when you're actually having a very full-scale training, helps also adjust the activities during the training. Creating the community, we already talked about that, and I would encourage everybody, and especially invite partners, to join in the upcoming activities. And finally, of course, it's not about the budget only money-wise, but also time-wise. Budgeting or dedicating resources to enhance the long-term sustainability and engagement of the national and local partners. I would like to thank you, and thanks also our of course, donors in Norway, in Germany, and partners at UNEP, Kreiswald-Meyer Center, and other Global Peatlands Initiative partners. Please do contact us. And finally, if I get to a little publicity, we're having new upcoming sessions on peatland monitoring starting later this year, for focusing on our 4 peatland countries. But we want to engage JICA and all of the partners present today here to join both in the design and implementation of these workshops. Thank you so much. Looking forward to your questions.
Okay, thank you, Maria, as the last speakers. And now we goes to the question and answer. We would like to invite one question from the floor. And there is several questions from online virtual meeting, and we would like to pick one. Is it okay? So we invite the speaker to come up in front. Ladies and gentlemen, from the floor, is there any questions? We give you one opportunity to ask question.
Or maybe we can just.
Okay. Okay, we can, while waiting from the floor, we would like to read the question from the virtual meeting. The question comes from the virtual meeting, goes to Mr. Hiroshi. If we fully apply to the technology, is it expected to total peatland area is larger than we have identified now? Your time to answer the question, please.
Okay, thank you very much for the nice question. So, our approach is just started, and we can compare with the existing peatland map created by Congo Peat. Then we need to verify our result with the Congo Peat map, and finally we can understand some differences or some correspondence from field survey experience. So the question is our approach will provide the much larger area than current area. So I cannot say yes or no, depend on the real condition from the field survey. Thank you very much.
Thank you, Professor, for the quick answer. And still not yet? Oh, okay. One question. So there was one from, yeah.
Speak into it. Okay.
Yeah, is sent directly to Wom. The question will goes to.
Well, it's to all the panel, but what I was understanding is once the mapping has taken place, how long do people think it would get to we can actually put a price on these wetlands, the peatlands, sorry. What price would we put on them? And in that way we could start to protect them better because they would become a very valuable asset. At what date in the future might that be possible? So my name is Chris Gentle from the World Energy Council. Thank you.
We would like to first from Mr. Osaki and then Mr. Professor Hiroshi to answer the question, and then maybe we have enough time. I would like to invite from the experience of Mr. Bambuta. The in this and simple answer.
So I'm not sure exactly what the questions, but we are trying to establish the whole systems, and so this is maybe little bit long times. And using the evaluation system, we promote it to the conservation or the restoration or management systems. So I difficult to say that this is a long time and very costly. But if once establish the system, which is very cheap for the each countries and the peoples.
Very much, Professor Hiroshi.
Okay, so your question is some post or something. I think it depends on the value. So if we can spend a lot of cost for the field survey analysis and so on, but if the result from the analysis is much more the cost to spend the survey or mapping, the result will be the depend on the value. So I don't know how to evaluate the result of the analysis and field survey, but maybe the Professor Osaki said we can evaluate the value or cost after the more longer period to conduct the survey and the analysis. So I don't know this is the answer or not. That is my answer. Thank you.
Thank you very much. And next, Mr. Bambuta, from your experience.
Je pense qu'il y a un besoin qui se pose. Les besoins, c'est lesquels? C'est que l'apport de tourbières soit capitalisé dans les efforts que le pays veut le fournir dans la lutte contre le changement climatique. Alors, compte tenu de cet apport, il est important que l'on puisse identifier cet écosystème partout où il se trouve. Il se pourrait maintenant que le pays ne puisse pas avoir assez de moyens pour ça, mais je pense que des synergies sont possibles entre organisations, entre structures, afin que chaque petite partie de cet écosystème puisse être cartographiée. Ça pourrait prendre du temps, ça pourrait prendre du temps, et ça pourrait aussi avoir nécessité beaucoup de moyens financiers, mais il est important que l'on puisse capitaliser cela afin de pouvoir trouver des réponses à la préoccupation, à la lutte contre le changement climatique. Là, je suis en train de donner une réponse politique. Je suis désolé de ne pas trop aller dans les chiffres, mais je pense que l'exercice mérite d'être poursuivi et mérite d'être fait, j'allais dire, quels que soient les moyens. Merci.
Thank you very much. Now, the last, Ibu Niken and also Pak Kato, and I would like to invite Maria to answer the question in short. And your experience of focus Ibu Niken.
We are currently working hard in the developing the system to evaluate the especially tropical peatland, and as I mentioned before, that we want the system to be simple, low cost, and then easy to maintain, so that it can be used for not only by the national or the government, but also the communities. And yeah, we hope that the system will be able soon, and then the value of tropical peatland can be determined accurately. Yeah, that's all from me.
Sorry, Maria, we have running the time, so unfortunately, I cannot give you the additional time. The organizer will already warning me. So, ladies and gentlemen, I would like to apologize for the limited time that we have and inconvenient for organize this session, because it seems that we all here running and running from the speaker to the other speakers. But I would like to note that indeed the technology and data collecting for peatland management is very important in terms of develop the policy in the government level and also the business and the community level to develop not only policies but what kind of monitoring, what kind of updating data in regular time that we have to conduct to get the proper data to prove what we have done so far in the peatland management so we can claim our achievement in terms peatland protection and management in correlation with greenhouse gas emission. So thank you very much for joining this session. I would like to return the time for Ms. Misaki. Thank you very much.
Yeah, thank you, Budi. Actually, Budi mentioned so many important things already, but let me summarize in the last before closing this session. Thank you so much for speakers for sharing your insightful experiences and also for audience to actively involving this session. I found so many questions online about the new findings of science on peatlands. And today we have gone through the remarkable works done by Policy Arena, academic, and on the peatland fields. I hope this session is deeply enough. As many of you may know, peatland conservation is a necessary and also has high potential in terms of addressing climate change. However, there are, those important points, three elements are not always discussed on the same table. So this is exactly the reason why we organizing this event. As a deputy director, Mr. Nishimura also mentioned in his opening remarks, also some other speakers as well, global partnerships and also knowledge sharing will continue to be a core when tackling and accelerate the peatland conservation. So we, JICA, will keep working on these very important topics and will welcome the opportunities to further work together with different stakeholders at different levels. So once again, I'd like to thank all four speakers, attendees, and organizers who made this session a great success. So for your information, this session is recorded already and it will be uploaded in the GPI website soon. And before closing this session, I'm happy to inform the participant at the venue. The food catering is waiting for you on the back. So please enjoy. And for online participants, unfortunately, the food will not deliver to you, but virtually, I will send my big thanks virtually to you. Thank you so much for joining. Have a nice lunchtime.